This video is brought to you by Altium Designer. In today's episode, you will learn how to make an IoT-based digital weighing scale using ESP32 Wi-Fi plus Bluetooth module, HX711 amplifier board, a load cell, and the new Blynk V2.0. Arduino and ESP32 are completely different controller boards. Arduino is a 5-volt compatible controller board, while the ESP32 Wi-Fi plus Bluetooth module is a 3.3 volt compatible controller board. And this is the reason the calibration value of the HX711 and load cell that works with the Arduino doesn't work with the ESP32 controller board. For ESP32, we will need to repeat the same calibration procedure again, and we will also need to reduce the speed of the ESP32 module. Previously, I used the same HX711 amplifier board and the same 5 kg load cell with the Arduino, and I explained the most basic things including the mechanical setup, load cell working mechanism, HX711 amplifier board technical specifications and its interfacing with Arduino, how to calibrate the HX711 and its programming. I'm going to continue with the same setup, but it's not compulsory. You can also get your load cell fixed on a wooden sheet, and it doesn't matter if you have a 5 kg or 10 kg or any other load cell, because the method I'm going to explain can be implemented on similar load cells and HX711 amplifier boards. Anyway, while fixing the load cell, pay a close attention to the arrowhead. It should be pointing in the downward direction. You can use any of these HX711 amplifier boards as both the modules have got the same pinouts. The only difference is in their size. So without any further delay, let's get started. I'm using my ESP32 development board. For now, forget about these relays and concentrate on the connections I'm going to explain. Connect the red and black wires of the load cell to the HX711 amplifier board E plus and E minus. Connect the white and green wires of the load cell to the HX711 amplifier board A minus and A plus respectively. Connect the VCC and ground pins of the HX711 board to the ESP32 3.3 volt and ground. Connect the SCK and DT pins to the ESP32 pins 19 and 23. You can follow this circuit diagram. If this is your first time using the ESP32 Wi-Fi plus Bluetooth module, then first of all you will need to install the ESP32 board in the Arduino IDE. You can also confirm this by going to the Tools menu. Then Board. You can clearly see ESP32 board is not available in the list. In order to program the ESP32 board using the Arduino IDE, first we need to install it. For this, go to my website and open my article on the ESP32 Arduino IDE Board Manager installation. Scroll down. Copy this link. Go back to the Arduino IDE. Now go to the File menu, then to Preferences, and paste the URL link in the Additional Boards Manager URLs. Next, go to the Tools menu, then to Board and click on the Boards Manager. Search for the ESP32. While the latest version is selected, click on the Install button and that's it. It may take several minutes depending on the internet speed on your side. Anyway, once the installation is completed, then you can go to the boards list to check if the ESP32 board has been installed. If you can see ESP32, then it means you have done everything correctly. Next, we will install the Blynk library. For this, go to the Sketch menu, then to Include Library and click on the Manage Libraries. Search for the Blynk and install it. As you can see on my side, it's already installed. Next, we will install the HX711 library. For this, go to the Sketch menu, then to Include Library and click on the aid.zip library. Browse to the location and select this zip folder. You can download this library from our website electronicclinic.com and click the Open button. As you can see, I have already added this library. The ESP32 board and all the required libraries have been installed. So now we can start with the Blynk web dashboard and Blynk IoT application. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for the delay, push, slide, and walk around faster than ever. Easily work together with your mechanical team and forget about the days of swapping design files. Every design change stays in sync between Altium Designer and SolidWorks PTC Crew, Autodesk Inventor, Autodesk Fusion 360 or Siemens NX. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. One of the best things about Altium Designer is that you can share your designs with your team members using Altium 365. They can check your design, leave comments, and if there are any issues, they can fix them from anywhere in the world. Altium Designer also uses the world's fastest component search engine, Octopart, so you won't have any difficulty in searching for components. Links to the Altium Designer, Altium 365 and Octopart are given in the description. I already have a getting started video on the ESP32 and the new Blynk V2.0, so if you're just getting started with the new Blynk V2.0, I'm going to recommend you guys should watch my previous video. For now, just follow the same exact steps, there isn't anything complicated. Copy the credentials. Open the IoT Weighing Scale programming, which you can download from our website electronicclinic.com. Paste the credentials. Select the ESP32 dev module and the communication port, and finally click on the upload button. Make sure you change the SSID and password. As you can see, the program has been uploaded. Now let's go back to the Blynk dashboard and check if we can receive the weight values. It's working. Now let's set up the Blynk IoT application. IoT weighing scale application is also ready. I'm going to power up my ESP32 development board using my created 4S lithium-ion battery, but you can also use a 12-volt adapter, or even you can use your laptop to power up the ESP32 module. The ESP32, my laptop and cell phone all are connected to the internet. You can use the same or different Wi-Fi networks. I'm going to start with this 2 kg weight, and let's see if my IoT weighing scale can accurately measure this weight. The weight value is a bit off. Next, I'm going to test my IoT weighing scale with this 3 kg weight. The difference is almost the same, 0.07 grams. This means we need to calibrate our weighing scale. Open the programming and play with this calibration factor value until you are happy with the final value. For me, this value worked, so you can start with this value. If it's worked for you, then okay, otherwise you can try different values. Anyway, I have already uploaded this program, and now let's watch the calibrated version of the IoT weighing scale in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.